My name is Jennifer Marsman, and I'm really excited to talk to you today about the cognitive services. The cognitive services are a really important part of what Microsoft is delivering in the machine learning space. What really gets me excited is that you probably have heard the term democratizing AI several times, right? You guys have heard Satya talking about it. You hear Microsoft constantly saying we want to democratize AI. The cognitive services are an amazing way to do that. Essentially what they are pre-built machine learning models that are available in the cloud that you can just call and use. And the reason I love this as a developer is because there are some problems that people solve over and over and over again. And it doesn't make sense to rewrite something. For example, I wouldn't write a square root function, right? It just doesn't make sense. I could probably do it, I'm a smart girl, but it doesn't make sense in that there's a whole bunch of well-tested libraries that already do that for me, so it's better to leverage something that's existing. So that's kind of how I think about the cognitive services. There's a whole bunch of common problems, things like facial detection and text sentiment analysis, and a lot of these other problems that people do over and over and over again. And so being able to leverage these well-used, well-tested models, I think helps me be productive faster. So today we're going to talk specifically about two parts of the cognitive services. We're going to focus on vision and speech. I'm going to start by kind of doing a quick overview of the cognitive services. I'm going to try to move through that pretty quickly, and then we'll dive into vision and into speech in a little bit more depth. All right? Here we go. All right. So the cognitive services are important for exactly the reason I mentioned. This gives you the ability to tap into pre-existing models. And these models pass a whole wide range of things. We've announced over 30 different cognitive services. And these are everything from vision to allow you to take an image or video and be able to derive insights from those. Speech, things like speech to text, text to speech, as well as things like speaker recognition. Language, so being able to do things like sentiment analysis and key phrase extraction on text, as well as our service Lewis, which allows you to map natural utterances that people would say to intents and be able to extract new ones as well. And then we have a rich knowledge graph that can allow you to find all kinds of interesting information and derive insights from the wonderful semantic graph that is the web. And then we have search APIs as well. And that allows you to tap into the power of Bing and be able to leverage things like a Bing image search or Bing News or just a general Bing search programmatically. And then finally, something new that we announced at Build earlier this year, is the Cognitive Services Labs. And these are kind of some interesting things that are still in development that are basically Microsoft research projects that have kind of just moved over to cognitive services. So it gives you an early chance to play with them and explore them as well. So in today's session, we're really going to focus on the first two. And that's, those are the vision and the speech. So that'll be the focus that we have today. And I do also want to call out the customization. So we have a whole bunch of amazing APIs that you see up here. We have vision, we have speech, and all the kind of things within them. But then we also announced a little bit more recently these customization services. So with all of these vision and APIs and things you see up here, you don't need to bring your own data, right? If you have the face API, you're leveraging a pre-built model. We have used a whole bunch of facial data to build that model for you, and you just call it, right? Now, you may want to move on from that. Maybe you have a problem where you have an assembly line plant and you make windshield wiper blades or something, and there's different parts that are coming down the line, and you want to be able to distinguish, this part from that part. And having something like custom vision allows you to train with your own data and then be able to build a classifier that can distinguish between A and B. So we'll look a little bit more about how to do that as well. And then custom speech is similar. It allows you to take kind of a baseline speech model and then extend it for your own domain. So for example, there may be things like a hospital, right, where you're using medicine jargon and you're using, give me 50 cc's of metachloramine, which is not a thing, I just made that up, I'm not a doctor. But some kind of language like that is not going to be in a typical lexicon. So having those types of things available can help you build it specific to your domain, so the kind of language that you're speaking, as well as specific to the acoustics of the room. So for example, if you wanted to do something with kind of a crowded background, so think a drive-through where there's a lot of background noise and maybe background music, being able to extract the text with those acoustic models can be a different challenge. And so custom speech can actually account for that as well. So before we dive into all of them, I do want to say why cognitive services. So Microsoft, one thing I love about Microsoft's machine learning offerings is that there's kind of a wide breadth of things that are offered for no matter where you are on your machine learning journey. So if you want to do, deep learning and bring a ton of data and build your own models, great. We have the CNTK. It's our open source deep learning framework that allows you to do that, our cognitive toolkit, also called the CNTK. We also have the Azure Machine Learning Workbench, and you guys may have heard the amazing announcements that were made on that yesterday at the keynote. And so the Azure Machine Learning Workbench allows you to also kind of build in whatever language you're comfortable with and monitor a lot of those things. And then finally, we have the cognitive services. Now, here's where I think the cognitive services really shines and the value adds that kind of make it stand out from some of the other things that our competitors offer and that we also offer at Microsoft. So first of all, the cognitive services are really easy, so easy. So it's basically you're just calling a REST endpoint, right? So you have a pre-baked model, and so if I want to do like a computer vision and I have a JPEG that I want to send out, I just take that JPEG, send it to a REST endpoint, and then I get back this treasure trove of information. So a lot of great information, but not a lot of work to be able to do it. So it's very simple to get up and running with that very quickly. Secondly, it's very flexible. As I said, you're just calling a REST endpoint. So we've made SDKs available in a lot of different languages. There's support for C# and as well as various things for iOS development. We have Objective-C for some and Swift for other cognitive service SDKs. We have Python support in Jupyter Notebooks. We have Android, Java things. We have Node. So there's a lot of different SDKs that are out there. But even if your language of choice is not out there, it's just calling a REST endpoint. So you can do it in Ruby. You can do it in whatever you want. Whatever language you want is possible. And then you can bring your own data. With those customization ones that I mentioned at the bottom, you can bring your own data to get even more customized experience. And then finally, these are well-tested APIs. So a lot of these cognitive services were born because we needed to do, solve some of these challenges internally. So we needed maybe sentiment analysis on text internally. And so someone on Microsoft Research was working on that, and at some point it was like, hey, wouldn't it be great if we made this available to everyone? So a lot of these products that you're using have been used for years internally. So these are things that have been developed using the decades of research we have in Microsoft Research, as well as the Bing team and the Azure Machine Learning team. Some great data scientists there. And then finally, we're trying to, we love our community, so we try to be active on Stack Overflow, on the MSDN forums, and make sure that we're answering questions and supporting people. We also have a lot of samples on GitHub. I'm going to point you to some of them today. So some of this code I'm going to be showing you today, you can go home and start coding with it right away tonight if you want to. I'll be sure to point out those links too as it makes sense. Okay, so there's a lot of real-world things you can do with the cognitive services, and I'm going to kind of talk through each of those 5 major categories of APIs. The first is vision. So with vision, you can answer questions like, what is in this image? That's what our computer vision API does. And so things like if it saw a picture like that, it may be able to recognize that those are people there. It may be able to recognize the number of faces. It could tell you, our content moderator service tells you whether that content is a little bit racy, for example. I can pull out the dominant colors and the accent colors. All of those types of things can be done with our computer vision API. We also have speech, and speech contains a number of things. So you might say something like, give me directions to the nearest local branch of whatever, maybe I'm on a bank's website or something like that. And so our speech APIs encompass everything from speech to text, and then text to speech, so speech synthesis. And then we also can do a speaker recognition too, which can be useful for something like if you have a call center and you want to be able to tell, okay, this was my support agent and this was the customer, and those types of things. Next, we have language. And so language allows you to get to the semantics of what is being said. So for example, if I were to ask, play today's customer call recording, the natural language processing that our service like LUIS, the Language Understanding Intelligence Service, can do allows you to extract that, okay, that natural language expression maps to the intent of play call, and then it maybe could figure out an entity within that, which is customer, so I specifically care about the customer call, and then maybe it can extract as well that the date is today, and then from there be able to play today's customer call. We also have a very rich knowledge graph API, a number of different things, everything from trying to traverse things like Wikipedia and grab some understanding from there, to academic and research papers. So there's a lot of rich things that can be done by understanding how these things are related. So something here you could ask is, what are the top publications in customer lifecycle trends, and be able to extract that sort of information. And then finally, you can leverage the power of the Bing APIs. And so you may say something like search for fraud prevention and do a Bing news search, and that would give me all of the latest news on fraud prevention. So a lot of really, really amazing things that you can do with the cognitive services. All right, and I did say it was easy, so let me just show you some quick code just to prove that it is. So in this case, this is specifically an instance of calling the computer vision API, which is part of our vision series of APIs. And in this case, all I'm doing is creating a new set of features, essentially, a collection of features here, and the reason I'm doing this is because you can get just a huge amount of data from that API. So sometimes you want to filter it down and say, okay, only give me the tags and the description instead of everything if you are network constrained or that sort of thing. So in this case, I'm requesting the tags and the description, and then I'm saying, just give me the file stream. So I point it to whatever picture I care about that I want to send up. File stream converts it to the stream of zeros and ones that make up that picture. And then I send that up to the cloud right here. This is using the C# API just by calling analyze image async, and that sends that stream of zeros and ones, and then the features that I care about as output. And on the back end, that gets turned into an HTTP post, and you can see it actually says as a query parameter that I care about the description and the tags, and then what I get back is some JSON that looks like this. So here are the tags that I care about, and in this case, this was a picture of a bird and a tree was the picture that was sent up. And so you can see things like outdoor was ranked very highly, and it was very sure that it was a bird, 95% confidence that it was a bird as well. And then it also gives you, in the description, it gives you the tags as well without the confidence levels. And then it gives you a caption, which is a short phrase that describes whatever the image is. And in this case, it was a partridge in a pear tree, which it in fact was. All right, so now let's kind of deep dive into the various APIs. So I want to cover vision, and then I want to cover custom vision, and then speech and custom speech. So we'll see if we can get through all of that. If we don't, custom speech was also covered by LUIS, I think, earlier today. So there's another great talk as well where that was done. And then a lot of the other cognitive APIs, the knowledge and the search are going to be covered by Brian King in a separate session as well. And I think there's also a lap around cognitive services. So a lot of other great sessions at this year's Ignite as well that you can check out. All right, so vision. Vision encompasses everything from computer vision, which is basically, describe what this image is to me, give me tags and descriptions and things like that. Our face API, which allows you to detect faces as well as do face verification. Is this face the same person as that face? Our emotion API, which distinguishes between 8 different emotions. Video API, which lets you edit various video aspects. Our content moderator, which is very useful for any time you're, if you're at a conference and they're displaying all the tweets up on a big wall or something and you want to run those real quick through content moderator to make sure that pictures and such are not a little too racy or something that shouldn't be displayed in a public place associated with your conference. You could use the content moderator to do that. And then we have custom vision, which allows you to feed in your own data and be able to distinguish between A and B. We'll go into a lot more depth on that one. And then the video indexer as well. And this is a fun one. This one was announced at, I think, the last build too, so it's one of the newer ones. And basically it combines several cognitive services together in a really compelling way to be able to get neat, interesting insights out of your video. So I'll show you that one in a little more depth too. So let's go through some of these a little bit more. So the computer vision API, this gives you a lot of different things. It allows you to analyze the image, and I'm going to show you in just a second all the JSON you get back from that API. It allows you to do optical character recognition, OCR, which is being able to find words in an image and then pull those out into a digital representation of those words. It allows you to generate thumbnails, so taking a smaller image. And then we also have a celebrity model as well, which is actually, if you're a media company or things like that, that can be very useful. And it contains over 200,000 different celebrities. So you can actually see, okay, you could build your own silly, what celebrity do I look the most like? But if in real world scenarios, there may be things like, hey, if I'm a large media company and I want, can you show me a picture of, such and such actor, like in a bathtub or something I need for this, fun thing that we're doing, this other spot. And there's all this media, being able to search that and find that actor in whatever context can be very useful. All right, so here's what that looks like in some detail. We have a whole lot of information. I'm not actually going to go through it here. I'd rather just show you the JSON on the website because you can see all of it there. But essentially, you get a ton of information, everything from characteristics of the image, so whether it's clip art, whether it's black and white, whether it's a line drawing, those types of things, to what's the content of it, to the colors. So there's a lot of great information that's available in the computer vision API. OCR is also part of computer vision, and so with OCR, you actually get back a list of all of the letters that we found in here. So for this particular image, you can see it's giving back life. It found the word life, and it gave it the bounding box. So these four actually draw a little boop, 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 boop around life, so showing me exactly where it is in the image. And then same thing with is, like, and then such and such. I didn't copy all of it, but it essentially shows you exactly what words were found and where they were found in the image. And then we have an emotion API. So the emotion API distinguishes between 8 different emotions. And you can see right here, we have surprise from both of these people, these adorable little faces here. And so there were 8 different emotions that we recognize between, and these emotions were chosen because they are kind of worldwide emotions. And so we tested on a variety of ages, a variety of ethnicities, a variety of cultures, so different expressions of these emotions to try to get a great, build a very strong model for these. And so with the emotion API, it actually returns, the JSON that returns, it doesn't just return one of the 8 emotion, it always returns all 8 emotions and then the percentage of confidence in each. So you may have some, Jennifer, my husband would tell you, there's a really great Jennifer expression that's like half sad, half mad, or half disappointed, half mad, or whatever. So you can kind of get that nice mix all in one and be able to pull out those distinct emotions as well. So that's what the JSON looks like there, where you get each of those, and you can see from this, you have to kind of look at the little exponents on the end, but if you account for all that, you'll see that the strongest one is this 0.995 for surprise, which shows that these guys are primarily just surprised. All right, and then finally, our face API. So this allows us to do a number of things. Facial detection, so I have this big image, where are the faces in the image, being able to pull out those bounding boxes. Facial verification, so if I have 2 faces, making sure that they are in fact the same person, if you wanted to verify identity or such. Finding similar faces, so there's actually a Boolean you can trigger for that particular call, where you can say, are these the same person? Or are these or is it someone who looks similar? So if you wanted to do, which celebrity do I look most like, you could use the similar face matching and it will find a celebrity with similar, face structure and that sort of thing. And then face grouping as well. So this, if you have a lot of different faces you want to group together like ones, you can do that. And then facial identification. You can train a model based on a particular facial image and then use that image to say, okay, if I have a couple of faces of Jennifer Marsman, be able to train a model to identify that this is, in fact, Jennifer Marsman. Okay, and so with the detection API, here's some of the things that we get. We do get the bounding box around the face, like you see here. We get a number of attributes. We do estimate age as well as gender. And I apologize on behalf of Microsoft if we ever get your age wrong or gender. It's using something very similar to what we do as humans. When you think about what we do as humans, I have a mental model of what certain ages look like in my head, right? Just from all the people I know and I've met over my lifetime and knowing how old they are, you kind of have a general sense of, okay, this face looks approximately this age. You kind of extract out those patterns, right? That's what we as humans do over a lifetime of knowing different faces and their ages. And so essentially that's exactly how machine learning works, right? We fed it a whole bunch of different faces with their ages, and then it found over time, in general, here's how I can kind of identify this. And I will say also, myself as a human being also has trouble with this. It's very hard for me to estimate age of people around me too. So if it's hard for a human, it's usually hard for a machine. Well, that's not always true, but and that's one case. And then you can see the grouping functionality. So in this case, there's multiple different pictures of this gentleman, and you can see him in different contexts here, and it was able to group that those were all the same person. And then if you have a name associated with several faces, you can identify that that is the person we want. All right, so let's actually, let me show you some of this. I'm gonna jump over here to my machine and just show you some JSON real quick and a quick example of using this in practice, and then we'll keep going. How many people have seen have used the cognitive services before in this room? Okay, cool. All right, just out of curiosity. All right, so computer vision here. So if we look at computer vision, you can see here one example, all of the data that you get back. So for example, in this particular image, you get back all the description, and we've seen a lot of these things right here, some of these great tags that are available. You can see them along with the confidence levels. If you call for tags specifically, you get the format, the dimensions. We know that it is not clip art, so that's returning 0. It's not a line drawing. A line drawing is essentially, think of a children's coloring book. It's essentially like a coloring book where it's like kind of the outline of something would be the line drawing. And then black and white, whether it's black and white or not, whether it's adult content or it's racy. The difference between those two, in case you're wondering, adult content is what you think it is. That's the really naughty stuff. Racy is something that is not inherently bad, but something that in the wrong context might not, like a woman in a bathing suit, which may be, appropriate if you're selling bathing suits, but maybe not appropriate if, in other scenarios. Okay. And then for the categories, we have various categories that we see there. Here's information from the face as well. So we got the age, the gender, the bounding box of the face, and then some dominant and accent colors as well. So a lot of great information you can pull right from here. And if you would like to try these things out yourself, you can just go to this website, which is Microsoft.com/cognitive, and go right here, browse, and upload your own pictures. So don't take my word for it. Go try it out yourself, see how well it works, and then I think hopefully you'll love it. Okay, so that's the computer vision. Let me also show you, just real quick, some of the JSON on the Face API. I won't spend too much time on this because it sounds like you guys have had some experience. But essentially, facial detection, you can see something very similar right here. Here's all the data that you get back from the Face API. So we temporarily assign a Face ID to each face that we see. That'll get recycled if you're not saving off the face long term. And then we have the face rectangle, so this gives you the bounding box that allows us to draw this little square around her face, the bounding box of where her face is within the image. And then a whole bunch of facial attributes. Now, if you haven't looked at this in a while, some stuff has changed. So we've added things like information on the hair. So in this case, she has a very low percentage of baldness. It's very funny because my manager actually shaved his head recently and tested the bald thing, and I was joking that he should go on like a Gillette or one of the like razor type commercials, just because he could guarantee a 0.00000 baldness. Like, look at that. And then the hair color comes back. So there's a lot of information on the hair color, and you can see that her hair color is primarily brown. That has the highest confidence and is returned first. And there's a lot of other things. The brightness of the smile is there, the head position in terms of pitch, roll, and yaw, the gender, the age, facial hair, glasses, so that's actually an enumeration between 4 values, reading glasses, sunglasses, no glasses, swim goggles, which is kind of funny. We actually had swim goggles, people wearing swim goggles in our training set. So that is included in there as well. And then one of the newer things that's been added is makeup. So you can see a Boolean on whether or not they're wearing makeup. And then the emotion API, you can see the response there, and she is primarily happy. And then there's some information on occlusion, so whether something is blocked. And then glasses, so we have an accessories category now, and then some information about the photo, like blur levels, exposure levels, noise levels, all of those. And then after that are the 27 facial landmarks. Okay, so that's kind of the JSON on what it looks like. Let me show you a little bit of an example. So how many people know or have played with the intelligent kiosk? Do you guys know about this demo? Have you seen this? So we usually have this at the booth. So if you have not seen this yet, you should get it. But the reason I'm going to tell you this is this contains a whole bunch of really fun examples of the cognitive services, and it's all on GitHub, all right? You can download it. I'm going to give you the link to download it in just a second. But then when you download it and you go here to the overview, you can see, here's a link to the GitHub code. So you can download all this code yourself and then play with it and extend it and submit a pull request if you want. If you add something cool, let us know. So all kinds of really cool stuff, but this is an amazing app. It's one of my favorites to do. And then I'm gonna give you the link in just a second on where to download it from the Windows Store. But this is a great example. It's got all kinds of fun things in here that you can use. So here's one example. This one we usually use at the booth a lot if you come by the AI section. How's the lighting? Ooh, overexposed. All right, so you can see right there, it's identified my face, it's doing that, and it's calling the cognitive services, so we can see here my age, my gender, and you can see I'm kind of happy right now because it's being kind to me with my age right now. And it spoke too soon, right? That's actually not, 29, I got in my 20s for a second, woohoo! And then it's also doing my sadness over there. So the fact that it was so mean about my age, maybe that made me sad. Very sad. So you can see how the overall sentiment is going down here. Very sad. So there's a couple of cool things that happened here. First of all is it's tracking demographics. So right now it believes it's seen 2 unique female faces, and that fact it's incorrect because I did just do a jump from my 20s to my 40s here. That was enough that I think it thought I was 2 distinct people there for a second. But in general, you can get a good sense for how many distinct people, because it's analyzed, it's making a call up to the cognitive services every second. And so you can see it's called it, it just reset itself, sorry. But you can see the number of faces that have been analyzed and then how many unique people have been seen. So in this case, it's analyzed 12 people, but it sees that I'm still the same person, so it hasn't incremented the uniqueness, all right? And then over time, imagine being at a trade show or doing a usability study and you're showing people your software and you're trying to get them excited about it. You could actually programmatically see how sentiment changes over time. And if there were more people here, like other people next to me, it's going to do the average sentiment across all people. So it will keep track of all of the faces it sees here and then the sentiment over time. So you can actually programmatically then map to, we demonstrated this feature and everybody was happy, or people were surprised, or those kind of things, or people were like a little disgusted or contemptuous or that kind of face. So you can see and have all that information over time. So really, really cool. This is one of my favorites. I absolutely love this. One other thing that's really fun that I'll show you just real quick because it shows you the different emotions. We have other things too, like some of these right here, this one and this one and this one are all basically like Snapchat features because since it's giving you, or Snapchat filters, I should say, remember with the Face API, we're actually getting those 27 facial landmarks. And so with those 27 facial landmarks, you can actually tell, here's exactly where those points are on my face and what they look like. So what I'm gonna do is show you one other thing, which is the emotion. I think this is neat as well because it shows you how, what exactly the 8 emotions are. So in this case, I'm more neutral. It'll override once it finds a better example of something. So it's using the confidence level as well. So if I act more surprised, it should overwrite my surprise a little bit. Sad. I am ready for my Academy Award. Look at that brilliant acting. Thank you, thank you. All right. So really, really fun. We'll have this available at the booth, so come join the other amazing people on the machine learning team, and you can come play with these. They're so much fun. And that's just some of them. There's a whole bunch of other really, really cool things around here. Here's one for driving. It will recognize yawning and that sort of thing and be able to alert you. So there's a whole lot of really neat demos in here, and you can download all of the source code. All right, so let's jump back here. All right, so we just saw, and that right there is the link to download the Intelligent Kiosk demo app and get to play with all of that, and use that code as a great starting point. It's aka.ms/kiosk app. All right. So next, I also want to spend some time on the video indexer and call that one out. So that's one of our newer services. So there hasn't been as many in-depth sessions on it. But essentially what's really cool about this is that it's combining a lot of the other cognitive services in a really powerful way. So essentially you upload a video to it, and it runs a number of cognitive services on it. It can do, with the video, it can recognize the faces in there, so it'll tell you exactly who is in the video. It can match it against that celebrity database that I mentioned before, so if there's well-known people in there, it can actually name them as well. It can do, it can extract all of the text. It can take the voice and do transcription, so you get a transcription of the entire thing there. It can do sentiment analysis, so it can track positive and negative over time. So there's a lot of really cool things you could do. So imagine you're going back to your company, and maybe you're the lucky one that got to go to Ignite, but there's a lot of other people who didn't get to go to Ignite your company, so you have to go back and kind of like summarize stuff for them. Like, how cool would it be to take the Ignite keynote, run it through the video indexer, and then be able to say, okay, maybe our company is like not into mixed reality yet, so we want to skip the mixed reality parts, but we're really into machine learning, so we want to jump straight to the machine learning stuff. So it allows you to easily kind of jump around in the video, pull out what's important, and jump to right where you care about. So let me show you an example of that. Like, here's kind of what it looks like, one quick screenshot, but let me show it to you for real, right here. I'm going to jump over here. So the index, it's vi.microsoft.com is our video indexer. And I'm going to pull that up on this machine right here. And so you can go to vi.microsoft.com or videoindexer.ai. Either one of those links will work. And then when you first log in, you'll see a screen that looks something like this. You can upload your own videos here. And then we also have some sample videos. So let me just show you one of our samples. So in this case, here is the build keynote from earlier this year. And you can see the video indexer running on it, and it's extracted out. You know our keynotes, we like to bring out a lot of different people to demo and stuff like that.
Good morning. How are you all doing?
Woohoo, Satya, I'm doing great. Okay, I'm going to pause you for a second, though. So you can see it extracted out. Here's Scott Guthrie, for example, and Satya, and Harry, and everyone. And it gives you a whole bunch of information about where they are in the video. So in this case, I can see that Scott appears in 20% of this video. So he owned 20% of the keynote, way to go. And then you can see he's actually matched in the celebrity database, so we can show his biography and find more information about him on Bing. And then it shows you, here's the parts where he's talking. So it actually shows you throughout the whole keynote duration, here's the things where he was talking, and you can jump to other people. I think Rima did a little demo right there, so you can see exactly where they are and jump to the parts that you care about. We also have the ability right here to extract out keywords. So this is based on we can transcribe it, and then one of the things in the cognitive services text analytics is being able to extract keywords. All right, so key phrases it's called. And so if I really care about, for example, Cosmos, and I got really excited about that and I wanted to show that to my team, I could be like, bam, jump right to the Cosmos section.
Today, I'm also really excited to announce Azure Cosmos DB, which is the...
So I could jump right to that part in the keynote and show everyone exactly what needed to be done, like right there, and be able to kind of process this whole thing a whole lot more efficiency. So we have Azure Functions, Graph, so it kind of pulled out the main things that people were talking about, Azure Batch, et cetera. And then you can jump right to where those things were. And then there's also some annotations here. So these are based on what it saw in the imagery, so it can show some of the things that were noticed here, monitors, computers, screenshots, things like that. And then you can also see the speech sentiment over time and how positive versus negative people were being in their language. So many cool things. And then a transcript right here, so you can actually see it and it will auto-scroll with you.
First globally distributed multi-model database service that delivers turnkey horizontal scale-out with guaranteed millisecond latency and uptime. And it's
all right, so you can see it's in real time, it actually can do that. And so you can jump to the places that you want to jump right here. It's all searchable. You can obviously search through it since we've transcribed it for you. So basically it's put together like text analytics and the face and the computer vision and a lot of other things, the emotion, like all these things are kind of packaged together into one neat little package to allow you to derive the greatest insights from your videos. So kind of a cool service and really easy to use. You just upload a video and go. All right, so let's keep going. So that was the vision service. You can tell that this is a Jennifer slide instead of one of the nice marketing slides because it is ugly. But this was essentially my brain dump of some of the things as a developer that were kind of like the gotchas or good things to know. So first of all, there's a whole bunch of samples and SDKs out there. They are on GitHub. I have a link right there to just one of them. That's for a computer vision sample. But there's a whole lot of different things out there. Some of the limitations I threw up there, so right now the computer vision works in English only. We're adding language support on all of them, but there's different varying amounts of language support for different things, but we do have the translator API to help kind of segue as well. The face API has a limit of 64 faces in one image, so if you have like a picture of your wedding where there's like 1 million people all in one picture, it may not get some of the smaller images. I kind of called out, here's what is supported for facial detection, just in case you ever wonder. And then the return faces are actually ordered by the size of the face. So people closer to the camera whose faces are bigger are going to be returned first, and then it'll get progressively smaller based on the size. So all kinds of really cool stuff right there I just wanted to call out. All right, so a couple of use cases and customer stories we have here. So one of them is Uber. Has anyone heard the Uber story before? Oh, no? Okay, cool. Well, this one is kind of neat. So if anyone here is an Uber driver, we have piloted something in the US, and I think it's going to go worldwide after that, where we worked with Uber, and they're using our facial verification API. So when a driver registers with Uber, they actually they submit their picture, and that's the picture that you see when you go for a ride and that sort of thing. But one problem that people worry about is, what if I just took my phone and handed it to my sister and let her drive for me? And if I'm an Uber driver, I've gone through a background check and all of that, but my sister may not have. And if she's driving under my account or under my name, then that's against Uber's policy and that sort of thing. And so what it does is when you're a driver, it occasionally asks you to take a selfie. Not while you're driving, but when you're logging in and such, you take a selfie, and then it will help it orient. So if it said, sometimes it tells you to remove your glasses if there's a glare and stuff like that. But you take a picture, and then it verifies that your face matches the face on file. So it's kind of a neat way to help protect passenger safety, as well as protect the drivers from having someone access their account. All right, and then another one that's kind of cool is Gray Meta. So they're a group that manages a kind of a digital library. So imagine them working with large media companies, and these large media companies, they have just like so much, like imagine one of these big television companies that has so much, they've made so many different TV shows and movies and such over the years, and they have all this B-roll and stuff. So there's all of this media, and then a lot of times they'll be looking for like either a certain person doing something or a certain kind of, okay, I need a picture of someone scared running up a flight of stairs for of some kind of promotion. And so I need a female scared running up a flight of stairs. And so being able to find that, what they've actually said is that a lot of times it is cheaper to reshoot the actual thing than to be able to find it. And that's a horrible problem. That's a problem we can solve, right? So taking and running things similar technologies to what you saw in that video analytics type thing to be able to make sense of all of their data. And also, since they're working with large media companies, they can match on celebrities. So if you are looking for a certain celebrity doing something, it can give you that capability as well. So a really neat service, and you can click on and read the full case study if you'd like to learn more. Oh, and then Brainshark, I won't spend too much time on them because they were discussed in, I think, Lewis's session, but this is another cool use of cognitive services where, in conjunction with HoloLens, where you can put on a HoloLens and actually train a salesperson. So the idea behind this was that it is really expensive to train sales folks, right? Because if you go in there and you blow a deal, then you've hopefully learned from that, but you've probably cost your company a lot of money by not getting that deal. And so the idea is, could we do this in a virtual environment? So they put on a HoloLens and they have a mock customer, a virtual customer that they talk to, and then they have to, they make their pitch and practice their sales pitches to this virtual person, and then it uses things like your text, your sentiment, how different aspects to actually judge how well you're doing with your pitch and to follow that company's best practices. And so that's it's a really cool story if you want to go read the kind of in-depth look at it. But it uses the face API, the emotion API, as well as text analytics for some of that sentiment and such. All right, so now let me jump into custom vision. So custom vision gives you the ability to take kind of these computer vision things, but go to the next level. So you can upload your own images, be able to train a classifier, and then be able to evaluate. So here's where this is good. If I wanted to distinguish, again, imagine this scenario where I have an assembly line and I want to distinguish between part A and part B. There's not a cognitive service for being able to distinguish between, a windshield wiper blade and a, gas pedal or something like that. So how do we build that ourselves? With cognitive services, with the custom vision API, it's very compelling because ordinarily to build a classifier to distinguish between two objects, you would need thousands of training images of each one of those things, and then you have to have a certain level of knowledge of deep learning to be able to build a classifier to do that effectively. What's really cool about custom vision is that you need maybe 30 or 100 images. So instead of thousands, we took that down. Depending on how much variety there are in your images as they're being processed, you could do as little as 30. I would recommend at least 30, maybe 50, or maybe 100 too. So kind of depending on how much diversity you have in the images that you're using. But a much, much, much smaller amount of data, and then you can distinguish between two objects. So let's look at that. And then you can actually use active learning, much like you can with Lewis. If any of you guys have experience with Lewis, you can help train it. So the things that gets wrong, you can mark and label those manually and then help the classifier learn best. All right? So here's kind of how it works at a level. I did a little, this is my PowerPoint animation skills. Thank you very much. So what you actually feed it is a bunch of labeled images. So here's a bunch of different pictures of cats, and I label those all as cat. And a bunch of different images of dog, and I label those as dogs. And I send those up to the custom vision service. And then it creates a model for me. And that's our training phase. And then when we actually want to use the model, what you do is send an unlabeled image up there. So now I just send a picture of a dog and I want to know what it is, and it should be able to output to me that is a dog based on what I've learned and what that model has learned. Does that make sense? So that's what custom vision can do. And then, this is very exciting. This was just announced last week. But we now have the ability to take those models that were created in custom vision service and export them. And right now, we have added support for iOS 11, the Core ML model format that Apple has created. And so we're doing that, and we're also working on Android currently, and that should be along shortly as well. So what that does is you build a model and train a model in the cloud, then you have the ability to export it and run it on your phone. And now when I'm using it on my phone, I'm not talking to the internet. So I'm not calling back up to the cloud, I'm not using data charges. It's faster, it's all on my phone. Okay, so I'm going to show you a demo of that in just a second. But the announcement was at that aka.ms custom vision service CSV export, and then there's actually some sample code you can use there if you want to take this and convert it to your own data. So in this case, we built a fruit classifier. But if you'd like to take this and apply it to like something in your different parts or something, you could do that as well pretty easily. And then the great folks at Xamarin actually took that sample and already did a port to Xamarin, so I included that as well. So there's a Xamarin version too if you're more comfortable in C# than Objective-C and Swift. Okay, so now I have a million demos for you on this one because it is so awesome. All right, so we're gonna go back here, and let me just show you first this. So this is the custom vision thing. So I just went to customvision.ai. So let me show you what I would do if I wanted to create a new project. So if I was gonna build one of these classifiers from scratch, it's just as easy as going to new project. I'm gonna call this the Ignite demo. I'm going to not put in a description. I do have to choose a domain. So when you're building complex neural nets, a lot of times you don't really need to build them from scratch. There's a lot of well-known base models out there. So what you can do is actually create use one of those base models to start with, and then be able to move forward here. So in this case, you could just do general. If you do want to be able to export it to iOS, like we just were talking about, then you should choose this general compact, and that will give you the support for exporting to Core ML. So we'll go ahead with that one, and let's hit Create Project. And it's going to create a new project for me here. And now it's just as simple as adding some images. So I'm going to hit Add Images, and I'm going to get rid of this and this. And let's go here and browse my local files. And I have some data right here, some fruit data. So let's take this apple data, for example, and hit this, and hit Open. And I have 124 images right there of apples. And so I want to give that the tag apple, and hit add that tag. You can actually do multiple tags, so I could give multiple different tags. If I wanted to tag it as fruit as well, I could also add fruit and give it 2 tags. And now I'm gonna go ahead and upload those. And that's gonna take a second, but then after I'm done with that, I would just go and add images again and do it as many times as I want, and then be able to move forward. So I'm gonna pull a Julia Child, because it does take a second for that to upload. And I'm gonna go back to Custom AI, and I'm gonna show you one that has already been built. So let me show you this cat-dog classifier. So if I click on this guy, once you've uploaded those pictures, they will appear here with the tag that you tagged them under. So I have 37 pictures that I tagged as cat and 45 that I tagged as dog. And then you just hit train. That will build a classifier for you. So very, very simple. And now I can actually run a test. So I took an image. So here's some of the dogs I did. You see I tried to choose a variety of breeds. Some of them are a little cut off, which is good. There's a variety of different backgrounds, which is good. And then different breeds of cats as well are after that, okay? So that's the data I chose. And then if I want to do a quick test, I'm going to use an image that I did not use in my training, just to see how well it does. And me being kind of a punk, I actually searched Bing for dogs that look like cats, and I found this breed right here, a Shiba Inu. Is anybody familiar with this breed? Okay. Well, apparently it does kind of look like a cat, because it's got the curly tail and like the ears or whatever. But so I can do that and send that up, and you can see that it did figure out that this was in fact a dog. All right, so kind of cool. It allows me to be pretty powerful and not have to have an extensive learning of deep learning, machine learning knowledge to be able to do something very, very powerful. All right. So you saw how to do that. You saw how to test it. I want to show you 2 more things real quick. One is I'm going to jump back to the intelligent kiosk real quick, because it actually does have a custom vision demo in it as well. So if you want to leverage some of this code, there's this custom vision explorer right here. And what the developer did here was Carlos created 3 different custom vision models. So one of them was traffic conditions. So imagine a traffic camera. And so he recorded a bunch of examples of heavy, light, and moderate traffic. There's one that differentiates between different types of vehicles. We have that as well. And then finally, weather conditions. So if I let me choose the weather conditions one here. And then I'm going to use this to do a Bing image search. So let me search for Seattle weather, for example, and see what it pulls up. And okay, yeah, we got all kinds of fun stuff right here. So let me select one of these. And you can see rainy was the winner. So all kinds of different things you can do here with these different things. So feel free to check out these, and you can grab your own images right here and run them through. But this is another example of how you might use this in practice. And then finally, the last thing I wanted to show you is an example of exporting to Core ML. So I do have an iPhone here that is running iOS 11, which is when the support for Core ML came out in Apple. And so what I'm going to do is, I'm using Air Server right here. It is connected to the same network as this. So if I click on Custom Vision right here and launch this Custom Vision app, you can see exactly what I see on my phone right here. And so I am going to now point this at an apple. I have some fruit here. And so this is the fruit classifier that we trained, and you can see this apple, it recognized is an apple. Very good. And then I also have here a banana, which is very not even yellow anymore, due to being in my purse for an extended amount of time, coming out here. But it still recognized as a banana. Good work. And then finally, this guy, an orange. Yeah! So you can see I can finally eat. I brought all this fruit. I can't tell you, you guys, I did this for you. I was so hungry in my hotel room last night, and all that fruit was just staring at me, and I wanted to eat my demo so badly. So after, these guys are goners pretty soon, I'm telling you. But there's our fruit demo. So you can see those were built with approximately a little over 100 images each. It also does, that we did support in there for pineapple and strawberries and some other stuff, but a pineapple was too big to carry, and strawberries are really messy when they get squished. So I gave you these 3 pieces, but really, really cool. And again, what's exciting about this is that you can use custom vision. You don't need that many images. And now this is not connecting to the cloud, right? This is just, it took that model that was built in custom vision, exported it, put it onto my phone, so now I can just run it locally and have it be able to tell me what kind of fruit it is just from my phone. So it's fast and not dependent on a network. All right, so let's jump back to here. And here's all the different things. So customvision.ai to get started. The intelligent kiosk that we saw for that weather example is still at kiosk app. And then there's a whole lot of great information on that export, and all those links are in the slide deck, which you can grab from the Ignite website after this. But CSV export is the blog post that Anna Roth did announcing this last week. All right, so a couple of best practices so that you can be good at it. So first of all, use at least 30 images for each tag. So if you want to differentiate between part A and part B on an assembly line, use at least 30 images, and then preferably even more than that if you're doing things. You shouldn't need thousands, but like maybe 100 if you have a lot of diversity in the backgrounds and things like that. So the images should be the focus of the picture. So if I was trying to do a dog versus cat classifier, I was doing all pictures that were primarily just the dog and just the cat, right? I wouldn't have a picture of me walking a dog with a Ferris wheel in the background, like that kind of thing. It's really like, should be just the dog, okay? And then make sure you're using sufficiently diverse images and backgrounds. So, for example, if I had a bunch of cats and the cats were all on a red background, and then a bunch of dogs and the dogs were all on a blue background, we're not actually telling it like what the focus of the thing is. It's just extracting patterns. And so if all of your dogs are on a blue background and all of your cats are on a red background, it might accidentally just build a red versus blue classifier. Okay, does that make sense? Because you're not really telling it what to do. It's just deriving patterns based on what it did. But if you have cats with a lot of different backgrounds, then it will extract that, okay, the pattern that is similar between all of these things is cat, and it will pull out the things that are unique to cat, the shape of the face, the ears, like those types of things, the tail. And then likewise with dogs. So make sure you're using kind of different backgrounds, different angles, different lighting. All of those things will be useful to be able to build the best, most generic classifier that will work best in the most situations. And then make sure you're training with images that are similar to the images that will be used in production. So examples of this. I actually did some facial recognition work with drones. And so I actually switched to drones like partway through the work, and I started with one drone and then switched to a different one, and the camera was much higher resolution on my second drone. And so the model that I had built using images from the first one did not work very well on the second one because I had built it with lower resolution pictures, and so it was trained to recognize what my face looked like at lower resolution. And so then when you move to something different, that can possibly throw it off. So if you have like a certain camera that you're using on an assembly line or certain lighting conditions, try to use those same things for your when you're training, and that will help. And then anything else that may vary, like if this is a customer app, like if I'm let's say a major washing machine company, and instead of having to, if my washing machine breaks down, instead of having to pull the washing machine out and like look for the serial number on the back, if I could just take a picture of my washing machine and it will give me the model number, the make, like all of that information for me, Like, that would be awesome. And so if it's a consumer, an end user that you don't have control over who is taking the picture, make sure you're training with enough background diversity of what different people's messy laundry rooms might look like in order to be able to capture that. Okay? Okay. And then we do support, when you sign in, we used to only support Microsoft accounts, but now we do support Microsoft accounts as well as Azure Active Directory. So you can log in with corporate accounts as well. All right, so a couple of gotchas I want to call out on Custom Vision. So version 1 does not do object detection. So it won't find, like if I do have me walking a dog with a Ferris wheel or whatever, it's not going to find the dog within that image. That's a problem called object detection, finding a smaller image within an image, and there's no support for that in V1. The second thing is, the way it works fundamentally is it was built to be robust across differences in the images. And that's why we can use only like 30, 50 images and be able to build a good classifier because it's more robust. But if you wanted to differentiate between, let's say on an assembly line, a working phone and a phone with like a crack in the screen, it probably wouldn't be able to differentiate between those because the crack is such a small thing. Like the thing that makes it robust enough to be able to use fewer training examples is probably not going to be, it's not going to be able to differentiate at that level of differences. Does that make sense? So things like defect detection, if they're very small type things like a cracked screen or whatever, it probably would not be able to pick up yet on that thing. If it's something very obvious like here's a part and here's a part broken into 4 little pieces, it'd probably be able to do something like that. But again. And then this is still in preview, so there are some limitations on the projects while they're in preview. There's limitations on the number of images and tags and how many things you can save, just while it's in preview. And if this is an issue for anyone, please reach out to me or anyone on the Custom Vision team, Anna Roth, Cornelia, Kelly, any of those folks, and we can talk to you about perhaps extending it if you have a production quality thing you want to start with. All right, so customer scenarios here. All right, I already mentioned the washing machine example. No having to pull out the appliance to be able to recognize something. Let me just take a picture and then bring up the service manual for me online. I would love that. Make that happen. Service engineers, identifying parts for ordering. Somebody brings in their something and there's a piece that broke off of it. Take a picture of the piece, automatically order it, that sort of thing. For manufacturing, I hesitated to put this one in here because I don't want to drive the wrong behavior. For the fault detection, so the difference would have to be very obvious. So small defect detection, it's not going to be able to do just because of the robustness of the algorithm. But if it's a very difference, like this one forgot to get stamped with this really big mark that is very easily noticeable, it may be able to do something like that. So if there's very obvious differences, it may be able to do that. And then finally, for data scientists, so one of the big things that data scientists have to do is label. If you want to build a supervised machine learning algorithm, you need historical data where, maybe I have a bunch of pictures of animals and I want to build something to figure out the health of an animal or something. And so I need to first label all of these images of animals with what kind of animal they are. Okay, that's kind of that's going to be a lot of manual work. Or I could build a quick custom vision thing and then have it automatically label all the cats, all the dogs, all the whatever for me. And so that might help me with my labeling, which I can then feed into a different machine learning algorithm. Okay, so a lot of cool stuff there. Okay, so a bunch of resources on this. CustomVision.ai is your place to go. There was also a Chalk Talk at Build where Anna and one of the devs talked about the C# SDK. So there is a C# SDK that's wrapped around this, and then there's Python and Node ones coming as well. And all of those things are available on GitHub right there at that link. So you can use those to make those calls. All right. And then finally, we have speech. So let's talk a little bit about speech. So within speech, we have a couple of different things. One is the actual speech API, so being able to convert speech to text. And then we have speech synthesis, so text into speech. So both ways we can do. We have a speaker recognition API. So this is very interesting if you wanted to call out, okay, who exactly is that voice? I know that would have been useful to me on a couple of conference calls where I don't know everybody really well. It's really nice to see who is that talking right now, that kind of functionality. And then we have our custom speech service as well, which I'll show you. All right, so let's just go straight to a demo on that one. I'm going to show you something here. You're probably going to want to copy down that link, dictate.ms. So this is an amazing thing, which is calling the Microsoft Cognitive Services, and it was implemented as an add-in for Office to allow you to just dictate to Office using the Cognitive Services. It is fabulous. So let me jump over to my demo machine. I will pull open Word, and I've already installed this from dictate.ms. And so now I'm just going to pull out the audio cable for a second because it will override the default microphone, and so hopefully this will work. Sometimes there are microphone issues with AV systems, but let's give it a try. So I'm going to start dictation and then have it try to write something for me here. Okay. Here we go. 77 years ago, our forefathers brought forth on this continent a new nation, conceived in liberty and dedicated to the proposition that all men are created equal. Booyah! Right? That was pretty good. So you can see, I can't tell you like how awesome this is, like just productivity-wise, how well this can help you, like in Office. You can write your emails with this, you guys. This works in Outlook. You can do this for PowerPoint. This is really, really cool. So this is using the Cognitive Services. They just wrote an add-in, but it's dictate.ms, so you can download that and use it as well. So very, very cool stuff here. The other thing I want to show you is a speaker recognition. So if I jump back to the Cognitive Services website, and I go back to just Cognitive Services, this level right here, and we are looking for speech now, so we'll go into speech. I will plug this back in since I don't need the mic anymore. And then we can do, so there's a translator speech, the Bing Speech API works great, the speaker recognition, so there's a neat demo here I can show you. So this was a neat model that was trained on presidents. So essentially what they did is they used like each president's inauguration speech to train a model to distinguish between the various presidents. So now if I play an audio clip, it's actually going to call that model and try to figure out which president is actually speaking. So
we gather because we have chosen hope over fear. Unity of purpose.
So you can tell it saw right here that it recognized that Barack Obama was the speaker there. And if we go here, let's try this one.
Americans are called to enact this promise in our
and
lives.
It saw that this was George W.
And in our laws.
Bush. And then let's see if it can get that versus the other George Bush.
And my first act as president
yes.
is a prayer.
And it did that as well.
I ask you to bow
cool. And then we have
today, a generation raised in the shadows
Clinton.
of the Cold War.
So kind of cool. So you can imagine different scenarios where this might be useful to figure out who exactly is talking and be able to automate that. So it did need some training data for each of the people we wanted to recognize, and then we're able to build a classifier like that. So pretty cool stuff. Okay, let me jump back here, and I think we're running just perfect on time. So the last thing I want to close with is the custom speech service right here. The custom speech service allows you to take kind of these awesome speech models and then customize them a little bit for your domain. I know we in the software development world, we have our own like acronyms that we throw around and things that probably don't make sense to people who aren't engineers. And so like we could maybe build a domain-specific model that understood kind of how we talk. So there's all kinds of things. So you have the ability to customize both language and acoustic models. So language is kind of the words that are used, and then acoustic models are the acoustics of the room. So the way I'm talking right now with a microphone and my voice thundering out is very different than if I'm kind of the acoustics of me, sitting next to a friend at a bar with all this background noise versus just talking normally. So there's all kinds of different scenarios. And so you can customize the model to be able to optimize for whatever kind of scenario it's going to be used in. So that's what we have here. So we're going to tailor it to the app and to the environment. And so you can record this audio, make transcriptions here, and then be able to adapt and deploy it and make it even better. One example that we have here, Starship Commander did there. I'm going to leave that in here. You can read the case study and watch the video. There's a link to that in there. But a whole bunch of great examples here. It's great for manufacturing, plant floor. A lot of times speech needs to be used because your hands are busy, you're doing things. Using speech can be a good example there, but it's noisy in a plant floor. A drive-through scenario can be really good to kind of record and see how people are doing there. And then call centers, of course, are the holy grail of speech that a lot of people are trying to look at how can we use and automate and have assistance for some call center to reduce support loads and help the support agents optimize what they're doing. So what I'm going to do here is there's actually some sample code. So if you go to that GitHub link, we have some sample transcription code for you. And it's biology data, a whole bunch of data, I think 50 audio files about people talking about the Jurassic and Triassic period. All right, so they're throwing out dinosaur names, they're throwing out, all kinds of things that are not in the general lexicon when people talk. And so we can train a model specifically to understand those types of things. And there's a walkthrough of how to implement it right here, and then you would go to chris.ai to get that all started. So let me actually show you that right now. If I jump back to my demo machine, I'm going to go here to the custom speech service. So first of all, let me show you the data. So if I go, where did I put my data? Sorry, I should have had this up for you guys. No, I downloaded it, so I think it's here. C code, it's a GitHub repo. So it's right here. Custom speech, sample on biology. Okay, so here's what we got. So there's two different things here. So first of all, it's the language model. So I mentioned that there was this language model and this acoustic model, right? So here's the language model, and this is just a bunch of text, right? So you don't actually need acoustics for a language model. So this just gives you a couple examples of the kinds of things that might be said. And can you guys read that okay? There's a whole bunch of just types of bobcats, different things, salamanders, Carboniferous, a lot of various dinosaur names, fungi kingdom. So it's a biology type things about different animals and life forms in the Jurassic and Triassic period. So this is just a couple of sentences of things that might be said. And then that's our language model. And then for our test model, we need two things. For an acoustic model, for our acoustic model, we need two things. So number one, we need a whole bunch of data. So let me give some examples here. No, not groove, hold on. Let me just do it in this one. Boom. Let's play with Windows Media Player.
Felis is the formal name of cats.
Is there any way for you to play that a little louder if I play it one more time? Let me do it one more time.
Felis is the formal name of cats.
Okay. Cool. So you can see there's a whole bunch of people saying different things right there. So that's the test data. And then what I did, it's a whole bunch of things in waveform. And then I took this all in one flat format and zipped it up into a zip file. So all of these things should be at the same level, no folders in there. And then you put it in a zip file. And then you also have a transcription file. And this takes this is a tab separated format. And it gives you, here's the WAV file, and here's the transcription of what they were actually saying. So the one that I just did was Felis is the formal name of cats, is what you just heard there. Okay? So now, to create the model, what I did was you just go to the custom speech, so it's chris.ai, right there, and I go first to this adaptation data, and here I was able to create my data sets, and so I created two different data sets. So with just that language data, I created a language data set. And then with the acoustic data set, if I try to grab that, you can create a name, and then you give that transcription file, and then the zipped up audio files right there, okay, just like I showed you. So I'm going to cancel that. So I built these two data sets here, and this one is even simpler. It just looks for the text file right here, so it's just a language text file as text. So you can create those and import them. It takes just a second to import. And then you can create these models. So once I had the data, I could create an acoustic model and a language model. So the acoustic model is based on that acoustic language. So you just hit create new. And basically, I just fed it that acoustic data and had it create that. And then same thing with the language models. I created that as well. And then I ran some accuracy tests. So if you see right here, here's the different tests I ran. In this case, I was using the conversational model. So this is like basically a baseline, along with my custom language model that I built. And you can see the word error rate was about 10%. And then I used the acoustic model along with the Microsoft conversational language model. So I kind of flipped these. I did a baseline here and then just this. And I got about 33% word error rate because I didn't know about the customized language. And then finally, I did both the acoustic model and the language model together, and I got a word error rate of only 2.86%. So I was able to very effectively do that. And I can show you one more example here if I have my airport kiosk. So this is something that was trained in an airport kiosk scenario. So imagine you're at an airport, you're asking questions, and you can do something like this.
Which flights offer economy fares?
Okay, so you can see this is what a baseline model would come up with that didn't have specialized knowledge of the flight domain. And here's what the custom model actually translated that with. And you can see how it does kind of a better job there. And we have a whole bunch of other examples like that as well to show kind of the power of these language models. All right. So if I jump back here, so you guys saw the biology data, and you guys can download that and try it yourself and then create your own data, and you saw the airport kiosk, which is a great example of using that in real life. So in summary, we went through a lot, hopefully. How many people learned something? Yes, okay, that's great to see. All right, so we tried to go into a little bit more depth in vision and in speech. We looked at both kind of the awesome models that are pre-built that you can just call and get this treasure trove of data back that we saw in JSON format. And then we also saw how to use these customizable ones. So the custom vision and the custom speech to allow you to add your own data and really tailor it to whatever your specific needs are. We have a bunch of resources for you as well. Again, that website that I kept going back to is Microsoft.com/cognitive. A lot of great samples right there where you can go to the website and just put in your own data. If you want to try your own image data and stuff, upload your own pictures, try out our stuff, kick the tires, feel free. It's really great. And then user voice, if you guys, how many people know about user voice? Okay, a few people. User voice is a way to give feedback back to Microsoft. So there's actually a user voice for the cognitive services. So you can go there, and basically if there's a feature you really, really want, like I really want support for the Norwegian language for this service, for example, you can go there, search for the feature first. If it already exists, upvote it. If it doesn't exist, put a new feature in there, and then try to get other people to upvote it. But the product team, everyone looks very closely at that data and what people are asking for, and then that allows you to kind of shape the product the way you want. And it's also nice if you really want to know what's coming, you can kind of snoop there, because they sometimes mark in development, or we're still thinking about it, like things you can kind of see actually what's coming, roadmap, if you nose around on user voice, but you didn't hear it from me. And then finally, our Stack Overflow tag is Microsoft-Cognitive. So if you want more information, or you have a question and such, Stack Overflow is a great place to go, as well as the MSDN forums. And then finally, all of this content is going to be recorded, so you can look for it online as well. Okay, so please evaluate this session. It's the only way I learn, and I am happy to take questions. Thank you, guys.